Okay, everybody. I'm Don Smith. I'm a professor at McGill University. I work in plant science, and I am heavily involved in biofuel net, and so I have an interest in biofuels. So today we're going to talk about why biofuels are better than fossil fuels. I mean, there are a number of reasons, but we're going to talk specifically about the main one. And if we look at these, to say, okay, what's the deal? If you look at biofuels, fossil fuels, you burn either one, you get CO2 in the end. So how are they different? What's different about the CO2 produced in each case? The big thing, it's all about timing. So if you look at it, carbon dioxide, CO2, this is the stuff that's produced when you oxidize fuel, and it also captures heat, and so it contributes to the warming of the Earth's atmosphere. So that's not a good thing, and we would rather not have too much of it. So what we do is what we'd like to do is move to biofuels, and I mentioned here it also contributes to ocean acidification, which is another building problem with all this. So this is, yeah, the long and the short of it, where the long and the short means the long time and the short time. So the deal is when carbon has been out of the atmosphere for, say, tens of billions to hundreds of billions of years, the Earth adjusts. There's long-term adjustments that take place, both in things like wind patterns, ocean currents, where ice is deposited, all of that. And the biosphere reacts to that. So the biosphere reacts by evolving. And so organisms evolve to a specific set of conditions in a specific area, and communities evolve to take advantage of the whole system in that area. And when things change, everything has to adjust. So when carbon then is dumped back into the atmosphere quickly, and whereas the atmosphere CO2 level had gone down very slowly and they'd adjusted, suddenly it shoots up again. When that happens, there's a number of things go on. Increasing temperature is one of them, but the kinds of things I just mentioned, shifts in ocean currents, wind directions, wind intensity, where ice is located, how often during the year, and for how long snow is present, all these things change, and the biosphere in the area has to adjust to those things. That's tough. So it's all about long-term versus short-term. If you're using these fossil fuels that have been buried in the soil for a long time, they were taken out over a very long period of time, everything adjusted, now back into the atmosphere very quickly. And if you look, we at the start of the Industrial Revolution, which seems like a long time ago in a way, but in terms of overall history was yesterday. And it was 260 parts per million then, and now we're at 400. So it's increasing rapidly, and that's a big challenge, how to adapt to all this. So there have been greenhouse gas effects already. We've had melting on various mountain glaciers, Greenland ice sheet, Arctic sea ice is melting. In fact, probably sometime in the next 10 years, we'll have a few days at the end of the summer where there's no consolidated Arctic sea ice. And you do see things like there's sailing now, ships across the top of North America, the famous Northwest Passage that people were looking for so intensely during the 17 and 1800s, and so many people died trying to find, is now open. So things like that. And I say mountain glaciers. My family and I visited the Athabasca Glacier in the Rocky Mountains in Canada, 6 years apart, twice, that is to say, 6 years, the times being 6 years apart. And between the first and the second time, it was 60 meters shorter. These things are happening. So in Canada, we're projected to reach something like 5 to 8 degrees centigrade warmer over the course of this century. Now, it's 5. What happens is these increases are greater at higher latitudes than at lower latitudes, and so it's 5 in lower Canada, but at higher latitudes up the north, it's greater, and so that's what's going on. We could expect to see an increased frequency of all kinds of extreme weather events. In fact, I've been having some thinking recently. I think what's interesting now is climate change. You see increasing frequency of things and increasing extremity of things. So more extreme, more often. What I'm thinking is that at some point, we're going to see a weather event that we haven't seen before. That'll be an interesting time when that occurs. So as I mentioned, the biosphere is responding. So you're seeing things like birds returning sooner into spring, plants flowering sooner, all of that. This is just a nice little graphic of the carbon cycle, what's happening. Various and sundry things release carbon into the air, including human activities, which can be, it could be combustion of biomaterials, which, the carbon was taken out of the atmosphere maybe a year ago, or 10 years ago if it's a tree, or maybe even 100 years ago if it's a really old tree. But it goes back into the atmosphere, and then it's taken out by photosynthesis again. But if it's stuff that was buried a long time ago, maybe 100 million years ago, that's the stuff that's been out of the atmosphere, and everything has adapted to it, and now it comes back in a hurry, and everything has to readapt. But it's coming quickly, so it's going to take a long time to readapt. But some of the changes will be quick, and there'll be a challenge for all parts of the planet, but all parts of the biosphere especially, and that includes us. So we should be, in some ways at least, have some self-interest about this because it's a worry for us as well. So this is just a sense of carbon gets buried and biomass carbon gets buried. And then once it's in the sedimentary rock, you have pressure, heat, not a lot of oxygen, and you get the production of hydrocarbons, which we then refine to make fuels for our cars, etc., but then combust and release you into the atmosphere, which is the problem. So biofuels, why are they better? They're fuels that are directly from this biomass that where the carbon dioxide came into the atmosphere in the last few years or decades at most. And so the material, again, it's also true actually, the stuff that's buried, the fossil fuel stuff also came out of the atmosphere and was also biologically produced. But the older stuff we think of as the fossil fuels, it's been there a long time. And this stuff is more concerning because it does release that CO2 that's been out of the atmosphere for a long time, and that everything has adapted to its not being there. So this is, sunlight. It's kind of interesting, really. You use sunlight and photosynthesis to really capture solar energy and attach it, sort of, to biomass, and then you oxidize the biomass in our oxidizing atmosphere, and you can extract energy and you can drive your car, etc. But that's how it works. And this is a nice little simple graphic around that. But the CO2 goes into the plant where energy is basically attached to it. It's reduced in our oxidizing atmosphere so that you can extract energy from it, get into fuel, the car, you can drive the car. CO2 goes back in the atmosphere. It's all very short term, and it results in no meaningful net increase in CO2. And in fact, if the fuels you use in the production of the plants for biofuel production are biofuels, you should be able to get to a position where you have no net CO2 production. So again, this is another one of the carbon cycle, and you can see the CO2 coming out from plants back into the car, well, back into fuel, into the car, and then back in the atmosphere. Or over on the left-hand side, fossil fuels coming out in the atmosphere for a net increase in atmospheric CO2 over short term, and causing an imbalance that then has to be re-equilibrated. And that takes time, and it's a major disruption, and things will shift around the globe, and it's a challenge for the biosphere. Things will settle down eventually, but it'll be a very difficult time for a while for all of the biosphere, and again, including us. So the main difference is time. Biofuels, short-term cycle, the time it takes to grow the feedstock material. So a year or two for grasses and things like this. But, and again, I should be clear here when I say grasses, this is cellulosic material. We're talking advanced biofuels. That's our main focus in this. But it's true also with the food material. But food materials get into a conflict with food versus fuel. That's got its own challenges in the long run. And a lot of those crops are produced with more intensive inputs of nitrogen and fertilizer that take energy. So biofuels, better in the short term, better in the long term probably as well. Whereas fossil fuels, they release that carbon that's been buried for a long time, and it moves quickly, so then we have to adapt again. The whole system has to adapt to it being back in the atmosphere again. So, okay, so why biofuels? It said reduce greenhouse gas emissions, so not as much, no net increase in the CO2 in the atmosphere. Independence from non-renewable oil, fracking and things have given us more oil resources than we thought we had right now, but nevertheless, it's still a non-renewable resource, and it's going to run out. Advanced biofuels can reduce greenhouse gas emissions by quite a lot. And I think, in fact, if we mined our soil carbon carefully and we use biofuels, drive our heavy equipment, when we produce the whatever plants are harvesting, it could be extremely little emission associated with extremely small amounts of CO2 emissions associated with the production of those fuels. Anyway, thank you very much from all of us at BiofuelNet, and